Let's take a look at your affirmation for MT2 LT3 on deductive reasoning. Now, deductive reasoning is using facts, rules, and definitions or properties to reach a logical conclusion. It's not following a pattern. Following a pattern is inductive reasoning. And so if we take a look at example 1 here, to estimate the population of a town in upcoming years, one of the town workers collected populations from past years and made this table. They want to estimate the population in 2025, 2028, and 2030. Well, to do this, are we going to use inductive or deductive? Well, we're not using facts here because we're going to look at a pattern to guess what's in the future. Anytime you're doing a guess, you're doing a conjecture. That's inductive reasoning. Algebra would be deductive reasoning, where you give an equation and we're going to use facts to find the answer. Now, with the law of detachment, we have two laws that go with conditionals. And the first one is called the law of detachment. And what it says is if I've got a true hypothesis, or a true conditional statement, I should say, and my hypothesis is true, then my conditional is true. Well, that seems pretty basic to start with. That is, hey, if the car is out of gas, then it will not start. Well, if the car is out of gas, what can you conclude? Well, you conclude the car will not start. But be careful, because if I tell you if it will not start, what conclusion you can make? The conclusion is it will not start. You can't go backwards with the law of detachment. Going backwards is illegal. So if we take a look at example 2 here, it says, if you study, then you're going to get a good grade. So John studied. What conclusion can you conclude? Well, we conclude John will get a good grade. Anne got a good grade. What conclusion can you make? Our conclusion is Anne got a good grade. Now we can do this with a Venn diagram. So with the Venn diagram, we're going to represent this. So if we take a look with a Venn diagram, we're going to put not a traditional Venn diagram where we have the two circles intersecting. We're going to have one circle inside the other. So if we take a look at our statement, if a triangle is equilateral, that's my hypothesis, then it's acute. We're told the triangle is equilateral. Therefore, we know it's acute. So what happens is my hypothesis goes in the smaller circle, and my conclusion would go into the larger circle when you represent something with a Venn diagram. That's what we did here.